Hello and welcome to the channel Great Britons. It's good to have you with us today. And I do hope you're going to enjoy the content today. I mean, we have an absolute cracker for you. We really do. We're going to be talking about the career of a wonderful lady called Dorothy Hodgkin, born in 1910 and sadly passed away in 1994. But she'd had an absolutely cracking career. She really had. I do hope you're going to enjoy the content. Please do remember to press the like button if you enjoy it. That makes a big difference to us in terms of the algorithms and all the other IT paraphernalia that, that surrounds it. Okay. And also, obviously, helps us to grow the channel and to push out some more wonderful content. So thank you for that. Please sit back and enjoy and listen to the wonderful career of Dorothy Hodgkin. Before I get into that, I just wanted to talk about a couple of things that preceded Dorothy's work. And they are, first of all, the discovery of insulin back in 1921 by a small group of guys working over at the University of Toronto. I also wanted to talk about penicillin, which was discovered by Alexander Fleming back in 1928. Rumor has it that was discovered quite by accident when he saw nasty things growing in a dish. So just shows you that there can be benefits by not always doing the washing up. Yes, I would say that, wouldn't I? So moving along to Dorothy Hodgkin. Her specialism was, well, basically using a thing called X-ray crystallography. And now I've just had a 10 minutes catch up on what X-ray crystallography is. And I must admit it went entirely over my head. But cut a long story short, it seems that you take a bunch of materials, you blast them with X-rays, excuse me, and then you measure the results of what sort of gets scattered around the room, I guess. It all sounds very interesting and slightly dangerous, I have to say. But there we go. That was what Dorothy was into. In 1964, she received a Nobel Prize in chemistry, which, wow, that's quite something. The Nobel Prize was for being able to look at the atomic structure of molecules within penicillin and insulin. Now, I think one of the things that occurred to me when I was doing research on this was that sometimes, yeah, accolades go to inventors and they go to people who have discovered things, and quite rightly so. Why not? They've done the work. They deserve some recognition for that. However, there are other times when it takes another skill set of a different person or group of people to come along and take an idea and substantially enhance it for the benefit of us all. And I think this is a good example of that. If we take the two products quite separately, so talking about insulin, first of all, for those of you that don't know, it's a product that is extracted from animals, or certainly was at the time, a thing that a lot of people would not approve of for various reasons. And it strikes me that if you were trying to gear up and produce huge quantities of this stuff for distribution all around the world, and it relied on, as I said, extracting from animals, it certainly wouldn't be the method of choice, would it? It certainly wouldn't be all that quick, I wouldn't have thought. Penicillin had its own problems as well. For those that maybe haven't sort of heard this one before, when people urinate, often 80% of what is urinated is actually penicillin. And it was the job of many nurses, I guess, to go around with volunteers and collect up all this urine, and then that would be converted back into penicillin. So obviously, it's kind of akin to a sort of blood donor bank, really, and fine for smaller quantities, I guess. But if you're trying to mass produce this stuff and get it all around the world, and you're relying on a queue of volunteers all dying to go to the loo, it doesn't seem the fastest method in the world. And so there we are. Yes, they were great ideas, and the discoveries of them were both wonderful, but as you can see, absolutely fraught with manufacturing difficulties on both counts. So this is where Dorothy's work really, really impacted both things, and kind of changed things forever. So by actually understanding the construction of penicillin and insulin, it's enabled chemists to then say, right, we now know how to make this stuff synthetically and in volume, and also it's going to be safer than it was before. So you've got a better product. You've got a product that is stable, that can be replicated in large volume and moved around the world quickly. And that is just an absolute game changer. It really is. And all down to Dorothy Hodgkin. Absolutely wonderful achievement. And again, someone who is well worthy of inclusion in our series on Great Britons. And I do hope you've enjoyed that. And please do click the like button if you did. So take care. I'll catch up with you soon. And until then, it's bye from me. Bye.